Hello class, welcome back to graphing, this time domain and range. I know you've all been waiting for that. So we'll go ahead and get started. We are going to look at it two different ways, graphically and algebraically, and some thought processes we should have while trying to figure out the domain and range. I'm sitting out on my back porch right now, and so you might hear some little birds in the background. It's a nice, beautiful Sunday after church, and it's a great day, so I'm just enjoying it. But I figured I'd take the time to help you with domain and range too, because you know, that's what I do. Okay, so first, before we get started, we do need some background information. Couple of things we need to be able to do is to be able to label the X and Y axis correctly. So if you look on the X axis here, this is the X axis, and when you see any arrows, that means they go on forever. So I want to make sure that we are clear that if we have that on a graph, if it goes on forever to the left, to the negative numbers, that is negative infinity, and to all the way to the positive numbers, forever would be positive infinity. And that works the same way with the y-axis. Same exact concept. If I have something that goes continually up, that's to the positive infinity. Continually down would be negative infinity. So it wouldn't be uncommon for you to see a domain written as negative infinity to positive infinity. Another way to write that is all real numbers. Also, let's talk brackets. The brackets can be either parentheses like this or brackets like that, or a combination of them. So what's the difference? Parentheses means that whatever number is here beside the parenthesis is not included in your answer. Okay? Where a bracket is where it is included. So let me see if I can create an example for you real quick. I'm just going to make a graph over here that, let's say, is this is an open circle here, and we're going to have just a line go to here, which is an open circle, or no, we'll make this one a closed circle. Okay, so if I were asking for instance, the domain, then that means I'm going to look from over to the left of the graph, the x values where they start to happen, and this is -5 right here. But -5 does not have a y value. So in that case, I'm going to use what's called the parentheses, which means -5 is where it stops, but it is not included. Okay, and then so -5, and then I have points on this graph that match the number line all the way to 4. Now when I get to 4, I notice the closed circle. The closed circle means that it is a bracket. So this is a situation where you could have both. Again, not including -4, but including 4. It's the difference in the brackets. And don't worry, we'll practice in class if that's confusing to you. And then a couple other things we need to talk about for when we work algebraically. The first one is that you cannot divide by a 0, and that is considered undefined. So you're going to be able to take things out of your domain if it gives you a 0 in the bottom. So that is illegal. You cannot have a 0 in the denominator. Okay, another thing algebraically working these that we want to look for is the negative under a square root. So let's look at the difference. See if I can. No, I was going to try to make this bigger if I could. But this is okay. Negative square root of 9 is -3. No problem there. But when you get to the square root of -9, that's something called an imaginary solution, and we are trying to graph on the real number system. So in this case, we would say that's not, that's undefined. Okay, so if I run into anything that gives me a negative under a radical, again, you want to take that out of the domain. Okay, so that's just some background information. Let's see kind of where it fits into our lesson. Okay, we're going to go through all of the graphs that we talked about in the last video and just find the domain and range of each of those. So we're going to start with the linear function, and what we're for the domain, we are going to watch for, should probably get a different color here. So for the domain, what we're looking for is all of the x values that work in this function. So if you think about it algebraically, can you think of any, if you think about the number line from negative infinity to infinity, can you think of any number that would make 2x plus 1 undefined? Well, no, there's any, you could plug in all the negative numbers, 0, positive numbers, everything gives you a y value. That means that every single number is part of your domain. And the way we say every single number is a couple different ways. We can do negative infinity to infinity, which is the same thing as all real numbers. So let's look at that graphically. That means I'm going to think about you want to kind of trace from left to right. So I'm tracing this graph, and here's the arrow. The arrow goes down forever. That means I have answers at -4 way down here, -5 way down here, -6 way down here. Every number that I try for, all the way down the number line, is going to have an answer on this line. So then at whatever this is would be at 0, 0 would be at 2, and everything, again, another arrow goes forever. So every single x value that I choose is going to have an answer somewhere on this red line. So that is going to be all real numbers. Okay, so now let's think range-wise. The range has to do with the y values. So the same concept, here's our number line for the y values, and we want to think about bottom to top. So if we look at this graph from the bottom, it has a y answer, everywhere, all the way down on both ways. So every the y points match with an x point on this graph somewhere. So they all have answers all the way up. So in that case, it would also be negative infinity to infinity. There's very few functions that have all real numbers, both domain and range. All right, let's look at the next one, a quadratic function. So here's the graph of our quadratic, which we know now is a parabola. And we also want to find, again, the domain and the range. So let's think algebraically again. If you think about this function, all the numbers on the number line, is there anything that would make this function undefined? Let's see, I could plug in all the negative numbers. Well, give me some answer. It might not be beautiful. It might be a decimal, or it could be anything. A 0, plug it in, I get -4. Plug in all my positive numbers, I always get y values out for any single x. So this is going to be the same thing, all real numbers. All right, now let's talk range. Range means what's going to come out of that function. There's got to be something that it can't be as far as the output. So what we're going to do is look down here on the graph, and I want you to think about taking a block and moving it. So if I started down here at the very bottom of the graph, and I only care about this x-axis, this point right here has a value, and so I can't really tell what that is. I'm going to say like maybe 45. It's probably like -6 1/4. So we'll just call it -6.25 because it's -6 1/4. All right, and then now anything below that, this graph has nothing below that. So I'm just going to think about starting here and working my way up the line. So here's a value, 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 value. Everything matches until I get to this top piece, which is going to go up forever, which means I'm going to continue to positive infinity. So I'm going to write this as, now notice that we're including -6.25. So I'm going to write this as -6.25 with a bracket because it's included all the way to infinity. You do have to write this in order from least to greatest. Okay, that's why it's always written that way. There's nothing on this graph that is below -6.25, so that's why I start there. Let's look at the next one, the absolute value function. So now let's think again, domain and range. The domain is going to be the very left of the graph. Let's do the same thing algebraically. Is there anything on this number line that will make absolute value of x undefined? Well, no, because I can take absolute value of all positive numbers, absolute value of 0, and absolute value of all negative numbers. Therefore, everything on the number line works in my domain. So again, that will be all real numbers. If you think about it graphically, my x-axis, which I don't have here for some reason, but my x-axis goes to positive infinity and negative infinity. If you look at it from left to right, there's a value for every single number. Okay, so for range, the lower part of the graph down here, because we want to do the range from bottom to top, starts at 2, it looks like. And then we're going to work up the graph and say, oh yeah, we got answers for that. So all the way up to positive infinity. So the way we'll write this is including the value 2 to infinity. All right, now for the square root function. This is going to have a different domain this time. I hope you can see that already before we even do it. And if you want to, you can pause the video and try it yourself first and then match it up. That might be a good idea. Okay, so let's think graphically. The square root of x minus 3. We already talked about that the square root of x could not be any negative numbers. So if you'll notice in the graph, that's why these negative values aren't used. They're not a part of my graph. That's because they can't be, because I can't have the square root of a negative number. So my values for the x-axis, which I'm only looking at here, are going to start at 0 and continue all the way. So we're going to call that including 0, because square root of 0 is 0, to positive infinity. You have to excuse my neighbors, they're talking loud. Okay, and then the range then is going to be from down here at, let's see, what would that be, at negative 3, I believe. So my range says that I can get a value of negative 3, but nothing lower than that. So I'm going to start that at negative 3, all the way to all these values. I want to see if they're part of my graph. Yes, they are, because this continues on forever. So it'll be negative 3 to infinity. And those are a lot of the parent functions that we're going to talk about. And finding those is where we're going to start. But then you're also going to learn something called piecewise functions, and that's this next one that you see here. So this is a little bit different. You will learn to graph these. Right now, let's just talk domain and range, though. So for the domain and range, for the domain, we only care about this x-axis and what values match. So this, let's see, the very left-hand side of the graph is here, and it matches this point, and that's at 1, 2, 3, 4, 5, 6. That's at negative 6. So that's all those values, and we have values here. Now what you see here is an open circle. Open circle means it is not defined. So at 2, we have a break there. So far, our domain is going to be from, since negative 6 has an open circle, it is not included. So it's from negative 6 to 2. 2 is also not included because of the open circles here. Okay, that means it is not included there. All right, and then but we can continue on because we have a little bit more happening here. So now let's pick back up at 2. All of these things work all the way to 5. So from 2 to 5, notice open circle, so that will be 2 to 5, again, included. So we have 2 different places on the x-axis that we have domains. The way that we include those is we put this symbol here called a union. So it's actually from negative 6 to 2, unioned with 2 to 5 is how we read that. All right, so now let's look at the range. The range is the bottom part of the graph, which is here at negative 1, 2, 3, 4, 5, 6, negative 6 again. And we're going to go all the way up to the very top of the graph, which is here at 5. Okay, so the way that we would name that one, look at the bottom here as open circle, so that would be from negative 6 for the range, all the way up to 5. Now let's talk about 5. 5 has an open circle here and an open circle here. but there's not open circles in between, which means those things are defined. So since we have somewhere that 5 is defined, we are actually going to include 5. Because all of these little points here, if it's in a line, all of these are actual points, X and Y. They just write them as a line because we're combining them together, but they are all points. It's infinitely many points. Okay, so I look forward to going over this with you tomorrow. If you can back up, if there's anything you want to watch again, to watch this video a couple of times, one time with notes and then again without taking notes, that's probably going to be the best bet for you. All right, I look forward to seeing you guys tomorrow.